Hello, uh, I'm going to work an example of a horizontal projection. So we have a question here that says a particle is projected horizontally with a speed of u. So that's an unknown from a point 122.5 meters above horizontal plane. The particle hits the plane at a point which is at a horizontal distance of 90 meters away from the starting point. So calculate the initial speed, which is u. So what is very important here is to quickly recall, before you answer this question, is to quickly recall what is a projectile motion, especially in the sense that it is horizontal. So a horizontal projectile motion has a trajectory that looks like this. Like this. So it is projected horizontally, so there is a force that pushes it in the horizontal direction this way, and as it is going horizontally, it keeps going at a speed um. It doesn't change its speed horizontally because there is no force of friction, air resistance, stated in the question. However, as it is going horizontally, it will get to the point where it will start to descend due to the force of gravity. So it will also have what we call a vertical displacement, which in this case I'm choosing to call S of y. And we have been told that this particle here, probably is a tennis ball, was 122.5 meters above the ground, or above the horizontal plane, which is this one. And at the same time, it needed to go, the trajectory it has to go sx 90 meters up until this point. So that's what we have been given here. What are the other assumptions associated with the horizontal projection that we can use right now? We understand that the initial velocity vertically going down is 0, and we understand that it will go down as a result of gravity, which is 9 meters per square second. That's the initial velocity. However, we know that horizontally it goes at u. Since acceleration horizontally is going to remain unchanged at 0, it will keep on going at the same speed until it reaches this position here. So we can resolve this question by resolving the vertical forces. So what we know is initial velocity in the vertical direction is 0, and the displacement is 122.5, and the gravity, the acceleration due to gravity, is 9.8, and what we don't know is t. So using our equations of motion, equations ut in the y direction plus half gt squared enables us to find t in this case. Since we know that initial velocity in the vertical direction is 0, this remains 0, plus half times 4.9 t squared. Okay, this is 9.8 actually. I've already calculated half of 9.8, so this is 9.8, and this is equal to 122.5. So this gives us an equation that says 122.5 is equal to 4.9 t squared, and making t the sum of the formula results in t squared equal to 25. This further implies that t is plus or minus 5 seconds. Obviously, you are going to ignore the negative and just conclude that t is 5 seconds, since time It's one directional here. Time is a scalar quantity. So we now know that this projectile takes 5 seconds to get to this point here, which is vertically 122.5 and horizontally 90 meters. So the question says find the initial velocity. So to find the initial velocity, now we are going to say horizontally, since acceleration is 0, what we know according to the formula, what we know now is horizontally, displacement is just v times t, which you usually call distance is speed times time. And since the displacement is 90 here and the velocity is u, the time is 5, this gives us 90 is equal to 5t, which further implies that t is 90 over 5, which is equal to 90 divided by 5. If I punch that into my calculator, I'll get u is equal to, this should be u actually, like this. This is going to give me u is 18 meters per second. Alright, so what is very important when you're solving a projection is to first preempt on the assumptions of that projectile before you attempt to answer the questions. Thank you.